Unit 1, Section 1. Section 1, Example 1, use inductive reasoning to determine if two odd numbers are multiplied together, will the product always be odd? When we use inductive reasoning, we do a number of examples to see if the pattern we're looking for holds. So we're going to do a few examples using two odd numbers and see if we multiply them together, we always get an odd number. Let's start using 3 and 7. 3 times 7, 21. That's odd. How about 9 and 21? Those are both odd. We have 189. Check, odd. 7 and 9, 63. Odd. It looks like we have a pattern, so the answer is yes. By inductive reasoning, if two odd numbers are multiplied together, will the product always be odd? And our answer is yes. Section 1, Example 2, use inductive reasoning to determine the next three numbers in the following sequences. In sequence A, we have 22, 26, 30, 34, and 38. We're going up by 4, plus 4, plus 4. And the pattern will continue, so our answer will be 38 plus 4, 42, plus 4 is 46, and plus 4 is 50. B, we have 3, -6, 12, -24. Often students find it easier to just think about the signs separately than the numbers. So we have a positive number, a negative number, a positive number, a negative number, and that will continue. Next, we would have a positive number, and then a negative number, and then a positive number. So I'm going to go over to my answer and put the signs in, positive, negative, and positive, so I don't forget them. Now I'm going to look at the numbers itself, ignoring the signs. So 3, 6, 12, 24. What we see is we're multiplying by 2 as we go up. If you didn't notice that, you might have said, well, I'm going up by 3, up by 6, up by 12, and you're doubling the numbers is another way to think of that. So you're taking whatever number it is and adding that number. That's another way to think of it. It works fine. So our next number would be 48, 96, and then times 2 again, 192. So my numbers with the signs will be plus 48, minus 196, and plus 192. C, 10, 8, 6, 4. So now we're going down. Minus 2, minus 2, minus 2. So our next three, we're going to have 4 minus 2 is 2, 2 minus 2 is 0, and 0 minus 2 is -2. Example 3. Pick any number, multiply it by 4, and add 6 to the result. Now divide that sum by 2 and subtract 3 from that quotient. Use inductive reasoning to look for a pattern in the relationship between the original number and the final answer. Use deductive reasoning to prove your conjecture. So with inductive reasoning, we're looking for the pattern. But with deductive reasoning, we have to prove using a variable. Let's start with inductive reasoning. So let me call this part A and this part B. So A, using inductive reasoning to look for a pattern, let's just start with a number 1. So we pick our number, multiply it by 4. 1 times 4 is 4. Add 6 to the result. 4 plus 6 is 10. Now divide that sum by 2. 10 divided by 2 gives us 5. And subtract 3 from that quotient. 5 minus 3 is 2. So we started with 1, and ended with 2. Let's try a bigger number. Let's try 7. So we're going to multiply it by 4. 7 times 4 is 28. I'm going to add 6 to the result, so 28 plus 6, 34. Now divide that by 2. 34 divided by 2 is 17. And subtract 3 from the results. 17 minus 3 is 14. So my result is 14 when I started with 7. I think I'm seeing a pattern. It looks like it multiplies it by 2. Let's try one more. Let's do 10. 10 is usually easy to work with. So I'm going to take 10 and multiply it by 4. I get 40. Add 6 to the result. So 40 plus 6, 46. Divide by 2. 46 divided by 2 is 23. And subtract 3 from the result. 23 minus 3 is 20. So I started with 10 and ended up with 20. So my conjecture is the procedure multiplies by 2. So that's using inductive reasoning to go from several cases to a rule multiplies by 2. Now we want to use deductive reasoning, which we use to prove it using a variable. So we're going to start with any number, so I have to start with n, or r, or s, just a number. Now I want to multiply it by 4. We know when we multiply 4 times n, we just write that as 4n. Now I need to add 6, so I get 4n plus 6. Now I need to divide that by 2. 4n plus 6 divided by 2. What we do is divide each part by 2. So 4n over 2 and 6 over 2. And that gives us 2n. 4n divided by 2 would be 2n. And 6 divided by 2 is 3. So I have 2n plus 3. Our last step is to subtract 3 from that quotient. So 2n plus 3 minus 3. And notice on the end we have plus 3 minus 3, which is just 0. So we have 2n by itself. So we started with n, and then we ended with 2n, which is what we said would happen is we multiply by 2. So the proof is done. Example 4, prove that the statement is false. All four-legged pets are cats. To prove something false in mathematics, what we look for is an example. You only need one example that shows something as false. And that example we call a counterexample. So for a counterexample of all four-legged pets are cats, I just need one pet that is not a cat and is four-legged, of course. So one four-legged pet that is not a cat. And my dog will do. A dog is a pet, four-legged, and not a cat. Example 5. Find the 35th term in the sequence A, B, C, D, A, B, C, D, A, B, etc. To figure out the 35th term, what we want to do is analyze the sequence. When does it repeat? We see that it repeats after 4. So every fourth, it's going to repeat. 1, 2, 3, 4. Then 5, 6, 7, 8, it repeats. Then 9, 10, 11, 12, it'll repeat. So what happens as we get up to 35? Well, we don't want to count all the way. We just want to say, Where does 35 fit in this group of numbers? Well, if we're bunching by 4s, we can take 35 and divide it by 4, and we get 8 with a remainder of 3. So how did I do that? Well, I know 35 divided by 4. If I do it on a calculator, I'm going to get 8 point something. Doesn't matter what the something is. Do it on your calculator, get something. So the whole number part is 8. And the whole number part that we've counted are these whole sequences. So we've done 8 of those whole sequences, which is 4 times 8. So that takes care of 32, and now we have 3 remaining, and that's our remainder. So if we have 3 remainder, it's here, 33, 34, 35. So our remainder of 3 means that we're using the same letter as the third letter in the sequence. So our answer is C. So what we do, divide by the length of the sequence and see what the whole number is. Multiply back to see how much of that number we've taken care of and see how much remains when you take that 35 that we're looking for and subtract that whole number part. That tells us our remainder. And that remainder tells you where you fit in that original sequence.